another session, guys. This is part B of the last lecture series that we had, and I really hope that the first example has motivated you or has shown you that the ways that we can use to find our roots. So we are continuing with the series of roots of complex numbers. This one, the root of complex numbers, and we'll be using these two equations basically. So without wasting more time, guys, thank you again for coming back to this YouTube channel, guys. If the videos are helping you, please hit that subscribe button, please like, please comment, please share. Let us go through, guys. Okay, they say we should find all four values of that complex number. Okay, now the term which I underlined there is very important. Okay, so the solution is that first thing first that we need to acknowledge is that n is equals to 4. Okay, all four roots, n is equals to 4. Thus n minus 1 is equals to 3. Okay, this plays an important role, in the general equation type of a scene. Okay, so let us find the modulus of that complex number. The modulus of a complex number is given by that. Again, I'm not going to show how I got that. You can look at the previous videos for you to know how I found that solution. Okay, and since only the real part exists, it means that our cos of theta is equals to negative 16 over 16, which is equals to negative 1, implies that our theta is equals to negative pi. Well, this is actually it's not negative pi, it's a positive pi. Sorry guys, it's a positive pi. Sorry about that, I got excited. Okay, why am I saying that that is true? Let us go back to this, our sine function and our cos function, where our cos is a negative 1. It's when our angle is pi. Sorry about that, guys. Now we have that, guys. Okay, and we can all agree that the value of theta that we have there, let me use a different color, the value of theta that we have there lies between negative pi and pi. So that is the correct one that we can use. Now let us write it in exponential form. Then this complex number in exponential form is given by 16 e to the I, and we're gonna have that angle pi plus 2k pi. This is nice. Okay, it's incredible, it's beautiful and stuff. So our value of k will be equals to 0, plus minus 1, plus minus 2, da 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 da. Okay, this is the complex number in exponential form, and in exponential forms, not form, guys. Form. English is running away from me. Sorry about that. So let us find the general equation. Ck will be equals to, now we're going to find the fourth root of 16, and we have e to the I, and everything that we see here, 2k pi, will be divided by 4, where our k now will be equals to 0, 1, 2, and our n minus 1 is equals to 3. Okay, so now we're going to find 1, 2, 3, 4 roots. As they said, we should find all four values of this thing. Okay, now this can be later expanded to 2e to the I, and have pi plus 2k pi divided by 4, where our k is equals to 0, 1, 2, 3. Okay, now this is just our general equation. We haven't done anything, but somebody else might love to write this as pi over 4 plus k pi divided by 2. It's the same thing, right? Okay, it's the same thing. If you choose to write it like this, it's still fine. If you choose to write it like this, it's still fine. But me personally, I would like to write it as 2ei pi over 4 plus k pi over 2. It helps me better, okay? But if you still want to write it like this, it's the same thing, guys, okay? It's the same thing. Now, let me fix this. Sorry about this, guy. It's running out of color. All right, yeah. So let us go and find our C0. Now C0. Now, guys, I'm not gonna write on K0 and stuff like that. By now, I believe that you know how to find that thing, okay? Pi over 4. So this will be equals to 2 cos of pi over 4 plus I sine of pi over 4. Pi over 4 is a special angle, okay? It's a special angle, so we need to respect it. We need to respect it a lot. So what will happen is that we can, okay, let me not speak too much and just write. Have 2, and then this one can be written as that plus I, 1 over the square root of 2. These guys can be, if we can use the sets rule, we need to multiply each and every term by the root of 2, and then 2 and then 2 will cancel. So you're gonna have the root of 2 and have 1 plus I. Basically is let me wrap this up, because many of you won't understand. So it's just the root of 2 plus I, the root of 2. So mathematically we like to write it as root of 2 1 plus I. Okay, so that's one of your roots. Let us find the second root. C1 2 EI. So now it's going to be 1 here, so it's going to be pi over 4 plus pi over 2. So this will be 2 EI 2. Now pi over 4 plus pi over 2 will basically be equal to 3 pi over 4, okay? Sorry about that, guys. Pi over 2. So this will be just 3 pi over 4. So this will be written as, let me just write it here, 2 cos of 3 pi over 4 plus I sine of 3 pi over 4. Okay, this will be equals to, now 3 pi over 4, it's also a special angle with respect to pi over 4. So my pen is running out, guys. 2 and have 1 over, actually this is okay, I'll show you just as we finish, guys. And then we're gonna have plus I 1 over the root of 2. Okay, so we're gonna do the same thing of multiplying by the root of 2 on these fractions, and then we're gonna have something of this nature. Let me write the root of 2 minus 1 plus I. Okay, so yeah, so I skipped this step from the previous example, and then yeah, now let us go and find C2. So we're gonna have 2I or 2e to the I, sorry about that, guys, pi over 4. Now here we're gonna have 2 and 2, so it's just gonna be pi. Okay, so it's just gonna be pi. Now this is just equals to 2e to the I. So pi over 4 plus pi is just 5 pi over 4, because we just multiplied this by 4 over 4. And then yeah, so this will be equals to 2 cos of 5 pi over 4 plus I sine of 5 pi over 4. Okay, so this will be equals to 2 cos of 5 pi over 4 will be now, okay, 1 over the root of 2. Do the same thing, multiply by the root of 2, so we're gonna get the root of 2 negative 1 minus I. Okay, so let us find the last one, C3. So we're gonna have 2 EI. So here we're gonna have pi over 4. So for k is equals to 3, so we're gonna have plus 3 pi over 2. Okay, So this will be just 2ei. Now 4, so multiply here by 2, multiply this by 2, so 6 plus that is going to be 7 pi over 4. Okay, 7 pi over 4, which this will be 2 cos of 7 pi over 4 plus I sine of 7 pi over 4. So this thing has been repeating itself over and over again. You're gonna see the beauty of it. Okay, so this will be just if you can guess this one, it's just going to be 1 over the root of 2 minus I 1 over the root of 2. Multiplying by the root of 2, you're going to get that root of 2 is 1 minus I. Okay, so now I want you to look at the roots that we have here. Okay, the first root that we have, oh sorry, let me remove this one. The first root that we have is this one. The second root that we have is this one. The third root is this one, and the fourth root is this one. Now you can see that they alternate. We started off with 2 positive, it's 1 plus I, and then 1 became negative, and then they both became negative, and I became negative. So it has been changing. It has been changing, going like this. Okay, so only the real part, both of them are positive, only the real part is negative, both of them are negative, and only the imaginary part is negative. Now, if that didn't convince you enough, let us look at the values of theta at the top. Okay, first value was pi over 4, and then it increased to, where is it? 3 pi over 4, increased to 5 pi over 4, and increased to 7 pi over 4. This is just the beauty of mathematics, guys. Okay, now without wasting more time, or actually the video is long enough, and I'll actually take another example. I'll have the third part of this one. For now, guys, if you got this far, guys, please do hit that like button and the subscribe button. I'll see you in the next video. Thank you.